Thanks. I'm glad to be here. I'm Lance Stafford. I'm the enterprise architect for our facilities engineering and process automation functions within Chevron. Essentially, my job is to deal with the data management problems at an enterprise level that deal with things like this. This is our LNG facility at Barrow Island in Australia. And so, as you can imagine, there's lots of information about this facility and the equipment associated with it. And this is just one of many that we have within Chevron. And hopefully you're a customer of us at some point in time. Little about Chevron. This is an obligatory slide that I'm required to give from our company. We're the second largest oil and gas company headquartered in the United States. 51,000 employees worldwide. 2.7 million barrels of oil a day equivalent that we produce. And then with our 5 refineries, that's 1.7 million barrels per day of refining capacity that we do with our infrastructure. Okay, we are an integrated oil company, meaning that all aspects of the supply chain, the upstream, we pull it out of the ground, we look for it, we pull it out of the ground, we transport it through various means, and then we refine it and get it into your gas tank and other products as quickly as we can. Okay. So I'm just going to talk a little bit about our journey with MarkLogic over the last couple of years to give you an idea of sort of how we've evolved our thinking and capabilities working with this company over the last few years. So we really started in January in 2015. Our downstream manufacturing business unit, the ones who take care of our refineries, needed to replace a portal that brought together structured data and then had a bunch of unstructured data kind of organized by the equipment, on a file server somewhere. Kind of hard for them to find stuff. They could get you to the directory, but they couldn't really get you into the data below in an organized fashion. So it was kind of 10-year-old technology, and they needed to replace it. So they brought in MarkLogic, and lo and behold, in 3 months with the POC pilot, they actually were able to turn it around and deliver the 360 refinery information management system data discovery platform that they use, and they liked it. It kind of replicated what they already had. Quick, it was fast, and it was done very quickly, which is kind of unheard of in Chevron. So that was a good thing, and then therefore that gave MarkLogic a platform to start kind of pounding the pavement within our company, looking for other opportunities, and that's where I actually ran into these guys. And we had a very similar problem. So in 2017, our health, environmental, and safety function, this corporate function, had very similar problems. We needed to pull together data from disparate systems, integrate it together, similar 360 portal. And so, pretty much replicated the same use case that we'd done in downstream, but with that corporate functions data itself. But this gave me an opportunity to kind of see kind of what was under the hood, kind of how it worked. And the fact that I could take structured data and turn it into semi-structured XML documents and be able to search that up and blend both the structured and the unstructured data together kind of resonated with me because I've been chasing a master data management problem in 2 different companies for about 10 years. And dealing with facility and equipment data, we have about 1,000 different types of equipment. We call them equipment classes. And as you can imagine, there's a lot of attributes for that equipment that's kind of similar, manufacturer, model, things like that. But then each class has a lot of attributes that are unique to it and dissimilar. And if you tried to model 1,000 types of things in a relational structure, you would really struggle with that. So the NoSQL format, the XML underlying data store format, that was kind of intriguing to me. And also the fact that that format could support things like at the attribute level, I could actually put attributes on the attributes. How confident did I feel about the score of the value that we landed in this attribute? Where did this attribute come from? If I had to broker data across different systems and one of them won, a survivorship rule, how would I know which one won? So how confident did I feel about that value? Where did it come from? And then as you start looking about integrating data across disparate systems, how do I figure out that this record is the same as this equipment record in this other system is the same as this equipment record in this other system? So being able to score and confidence score the individual rows themselves in addition to the attributes was an important thing. And it really kind of occurred to me that with this format, and managing data in this way, that was a way that we could solve a master data management problem that has kind of been challenging me for a couple of years. So that kicked off a project called our Asset Data Store, which was a 360 review of the equipment. It's a master data management approach for that system. And we kicked it off in January of 2018. As we were halfway through that, we saw another opportunity with our R&D function to say, okay, we've ingested quite a bit of test data for this equipment, but now we've had a long-standing data challenge with associating sensor data with the fixed equipment that it belongs to. Either these sensors are directly connected to that piece of equipment, or they're somewhere farther down in sort of a network of equipment, and we care about that value being applied to models that we would apply to this equipment. So the engineers who are looking at corrosion and integrity-related things, they want to take these parameters, this real-time data, and mix it with master data on the equipment record itself, and blend that together and build models and come up with analytics. And so this was a project that says, hey, what do we do about solving that data problem where we'd have these misconnected attribute value pair data in a time series context and associating it with the master data that's related to the equipment. So we built a little application that kind of through a work process allowed that association of that context data, giving context to the sensors to tie it into the equipment records itself. And so that was an R&D bolt-on that we put as a use case on top of a master data management platform. Okay, and then today, and I'll take you through kind of where we are today with these projects. But as we stand today, our company is going through, a full relook at how we do business in a digital context. What these things that we want to call digital platforms, where we're looking at putting data services and process services on top of everything for our various functions in our business. So how do we serve that data up for consumers that are both in the cloud, on-premise? How do we deal with getting data consistently across different functions? Because if you're an HES, you're using equipment data. If you're an FE, you're using equipment data. If you're using our operations guys, you're using equipment data, and lo and behold, it's the exact same data. We just don't think about it that way, and our systems are siloed that it's hard to bring that data together. As we went through this journey, a couple of the capabilities that we were able to work through, started out, hey, let's bring together structured and unstructured data together in a data discovery context. From that, when we worked with the HES platform, they needed to secure the data. They needed to say, well, this business unit can see this and this business unit can't. These people in these groups can see these attributes, but these others can't. So we applied sort of the security context in the data itself. Then we went up and added new data types into the mix, facility and data mastering capabilities. All along, we needed to model the data. We wanted to get to an enterprise view of how we treat facility and equipment and be able to serve that up in a consistent manner. So that led us to defining a canonical model for shaping the data that came in from these disparate sources, matching and merging it together, and making that sort of the key of what we were trying to do. As part of that, we would score and give quality confidences to both the attributes and the associations of the data itself. And as I talked about, we did tied sensor data to the equipment. One of the key things, though, that we needed to do was how do we bring this integration together without solely relying on programmers to write scripts to do this. We really needed user interfaces to be able to have somebody like a business analyst be able to say, this is how I can bring data in from a raw format, map it to the canonical model, be able to say, I like this field at this data source better than this field in that data source, so it should win. And then have some rules in place where you could write some JavaScript functions or something, and then they could override as a second pass if there's business logic. So that whole platform that we put together was sort of where we landed with our Asset Data Store project. I think I talked about that in a little bit more detail. So, why did we do it? How did we sell it? Well, we really needed to bust the silos. We have 12 instances of 4 different flavors of work order management systems in Chevron. In Chevron is why have one when you can have 12. With inspection systems, we had 16 instances of 6 different flavors of a system. And each one of these got stood up independently, different project manager over time, configured differently. And the long-term thought process of, hey, we have to bring this all together to do things like data science and data analytics and analyze across the entire fleet, across the company, that wasn't thought of when they were originally put together. Now, that's what we're all about. Data lakes, data analytics, data science, that's the belle of the ball right now. But trying to make that happen in real time is a major challenge. So we needed to be able to help support that capability. Busting the silos, making sure that the data was shared across multiple functions, that was one of our requirements. The data itself was inconsistent. It was inconsistent in how it was structured. It was inconsistent on how it was keyed. It was inconsistent on what was filled out. So we have to be able to work with rules that dealt with each of those problems. And finally, we wanted a technology that would actually help us, have a one-stop shop for solving this problem. And that was sort of the requirements that we brought into forming this asset data store capability. So why do we care? This is our slide that we use for our business customers is, what is master data? Well, if you go into a grocery store and you want to buy a potato, a baking potato, depending on which store you go into, they'll call it a russet potato, they'll call it a baking potato, they'll call it a golden delicious potato. But at the end of the day, it's a potato. And it's a potato of the same thing. And when you go and you check it out, then there are characteristics about it that you would attach to the potato. Where was it purchased from? Where was it procured? Where was it transported? Those are all satellite data, all related to the master data of a potato. So when we get right down to it, when we talk about master data for things, it's all just potatoes, how we think about that. Again, another reason why we would do this is our IT philosophy and the requirements and principles within Chevron, our guiding principles, which is, we want to get the right data to the right person at the right time. Master data allows for a single, comprehensive, harmonized view of a piece of equipment or a facility or reference data that is related to this function. So we needed to bring consistency to essentially chaos that exists in our silos. Standardization. So we wanted to be able to make data consistent in format, consistent in quality, and recognizable across the whole value chain. So that was critical as well too. To do that, you have to integrate it. You have to be able to say this record is the same as that record is the same as that record, or this record is a child of this record. And this is where you can get some of the semantic relationships and get a little bit smarter than, say, a pure relational link between the data. So that was one of the things that really helped us out quite a bit too for some of these queries. For example, when we associated a process automation tag with a piece of master data equipment, we said this thing is directly connected to it, or it's indirectly connected to it, or it's upstream of in the network, or it's downstream of the network. So you added sort of context-based semantic logic about how this relationship worked. And then finally, the business process optimization. Being able to bring that data together now lets us do things that we've been wanting to do. The data sciences, the data analytics, the fleet analytics. You have to do this as a precondition to get real value out of these processes. And we're in that journey, trying to get that value out to our customers as quickly as we can. So what are some of the problems we ran into when trying to master the data? Well, it comes down to, how do you associate and find the record across different systems? For the facility and for the equipment data space, the way we determine where a piece of equipment is essentially through a hierarchy, a location hierarchy. This piece of equipment is in this facility. It's part of this business unit, which is part of this processing unit within the facility itself, which is within this area, and then we give it this label called a functional location. So those components together really make up sort of a natural key of how you would identify uniquely what a piece of equipment is in our facility. So, in the last couple of decades or whatever, we've been doing a lot with system keys, and using natural keys to associate data across systems is almost kind of a lost art. And we needed to come back to that. To integrate data across systems that are disparate, you got to look for keys that are human readable and able to be associated, because you will see them here and you'll see them there. And they might be a little bit different, but you can kind of tie them together with semantics and logic and processing and things like that. The other problem is we have lots of different hierarchies that we need to represent. So we have hierarchies that are related to where it's stored, where this thing is geographically, in which state, what county, country, all of that. We have hierarchies about who's maintaining it, who's running it, who's doing the operational context of it, where it lives in our financial organization, what cost centers it's associated with. So that's all that data we also want to be able to capture about that piece of data or that piece of equipment. And that's just on the logical side. When we get on the physical side of the data, which we want to tie into the same object, is where do we procure it from? What are its material characteristics? So there's a whole tranche of data about that piece of equipment that for different processes, analytics or whatnot, we might bring in and be able to organize. And the semi-structured XML format that underlies this, the NoSQL approach, is very useful for us to be able to pull that data together. So to give you an example, is we might be in an inspection system, and this is the hierarchy of how we would identify a particular heat exchanger that we're trying to link across. So this would be a heat exchanger 42. That's not really what it's called. That's not even what the format looks like, but it's simplified. It's in our Alba offshore platform. Happens to be in the country of Scotland, which is in the North Sea, although we call it N.C Limited, which is really kind of a legal entity rather than an area. And it's in our upstream business, okay? And maybe that's how they captured it in the inspection system. But when we go over to the work order management system, okay, well, upstream was pretty consistent. Okay, we realize that. But they actually put it into an area context. They called it Chevron North Sea. As a human, I know that those are equivalent, but as a machine, they won't unless you put in logic to say those are equivalent, a semantic or a dictionary to do that. Yeah, I would match on the platform. But I actually have an added part here is that I actually have the unit, the mud cooling unit that this piece of equipment in. That data wasn't in the inspection system, but it's kind of a key piece when we're trying to say, with any precision, where is this piece of equipment located? So in this case, we would be using that data to enhance and perfect what the final record would look like. Okay, and then with the tag itself, in this case, it looks identical. In many cases, we have to do a lot of processing on the functional location to make it look as close as possible so we can do a match on it. So that's some of the rules that we have to put in place. So again, this is sort of the things where there's the differences that come in. And the whole goal of this is to bring this data together into a consolidated master view that deals with some of the data imperfections from the originating systems, gets them aligned to a standard taxonomy, a standard canonical model. We do translations of values to get to standard reference list values. And again, if you've done master data management at any time, whether you're successful or not, these are all the things that you have to do in order to get good quality, valuable master data records out to your systems. Okay? And let me see where we're going to go with this. So, specifically, we did get some help in implementing this capability at the low level. And that's where we were able to, we started out kind of in parallel with the MarkLogic tech group, and then they ended up putting a lot of the smart mastering capabilities into their product, and we could start, moving stuff back and forth and using some of this functionality. So again, if you look at, what the smart mastering capabilities in the hub framework would do for you, is you got to define the data services. I'm going to let Damon talk about this in more detail, but you load, discover the data. Our business analysts using user interfaces will map the data. The logic will harmonize the data and curate the data. And then when we serve it up, each object that we define, by default has an API, a REST services API, that we will expose. Or if not a REST services API, in some cases we build ODBC entry points for technologies that are more friendly to ODBC than REST services. So we serve it up. And all part of that is the match, the merge, and the refinement of the record in order to get it out to customers and to other aspects of the ecosystem that we're trying to bring the data to. if you look at the process, and you've seen various flavors of this today, as they just talked about, what's in the Data Hub framework, how does the Data Hub framework work, is we ingest the data from various sources. So we do extracts from multiple systems, engineering systems, work order management systems, inspection systems. There's a whole laundry list of systems that we're going to do more extracts from. And we just load it up, into the raw database inside of the MarkLogic platform. Then basically we start getting our business analysts to go through and use a UI to map from source to target. We apply through sort of a transformation scripting in our UI, reference data lookup for those fields that do have reference lists that we want standardized at an enterprise level. We look at a combination of these attributes to say what is the natural key that will give us the best chance of mapping this record to a record in another system. So we set up and define which columns are the likely natural key. We then kick it into a process that does the match and merge, which is sort of the underlying capabilities in the Data Hub framework. We score it based on sort of scores that we originally defined in the mapping, plus other logic that comes in that we've noticed as we've gone through this, bringing this data in. So we have some coded rules that operate behind the scenes. And then, hopefully we get a high percentage match, and a lot of this does, a lot of the work for us, but there's inevitably fallout in this process. And so that data that doesn't hit a certain confidence level falls out and has to be reviewed by a human, essentially. So we put together a user interface to allow someone to look at the data that didn't quite make it or had a low confidence score, and then they could specifically say, yep, this is the same as this one, this is the same as this one. If there was a match that actually happened erroneously, they could say, nah, unmatch that one. And so it's a workflow-driven user interface to help us link the fallout of the data that didn't make it through the rules. So that was the review part of that. And at the end of the day, when you get to the end of it, hopefully you've mastered the business data that you were trying to bring in, whether it was a list of facilities, list of equipment, list of work orders, list of inspections, a list of incidents, things like that. That's kind of where you're trying to get to as you define information objects in your business that you need to be able to pull together from multiple sources. So again, the matching and merging, we're going to focus on that a little bit. If you get right down to the details, sorry, this is a bit data-like, but we're storing our data through XML. And as I showed before, this is sort of the differences in the data that you would see in the documents that we bring in from the various sources. And you would apply the harmonizing, the match and merge scoring methodology per attribute to see, what kind of a match do I end up with. And so it's just an algorithm that kind of gives us sort of this confidence score that says, if I looked at these two documents that I brought in, I'm at about an 80% confidence that they're the same record. Okay? If I look at the record after it's been mastered, I talked a lot about, the thing that I was looking for in that data format was the lineage and the ability to say what was my data confidence per attribute? Where did this data come from? Which rule fired and won to give me the value? So within the XML itself, that's what we're doing. We're saying the source, this attribute came from the work order management system. It won. In fact, most of them won coming in from the work order management system, except for the equipment identifier and the country. That came, we seem to like the inspection system better for some reason. And so that's what we've been able to do as part of the output of this process and the harmonization, is put lineage and scoring into the output record, okay, and the provenance of where that came from. Okay. So again, if you look at kind of the sum up sort of what our solution approach was, deal with disparate values across systems and try to identify when we're talking about the same thing, but the value's off a little bit. So there's a little bit of processing we do with that. Be able to work through the different hierarchies and establish a natural key that can be expanded across different data sources for linking purposes. Deal with the fact that we have idiomatic conventions that, if you call it North Sea or Scotland, that Scotland's in North Sea, so you can kind of build those kind of relationships. And then finally, being able to have a customizable confidence that's either manually entered or overridden by some back office process that we've coded up through a developer. Okay. So what's the benefit of this? Well, as I've been talking about all along, we get standard data available to any consumer out there. We've got aligned the data across the critical functions that we need to take care of our assets, which is facilities engineering, base business, health, environmental, and safety. We get data that crosses division and operating companies within Chevron. Again, we're finding that we want to do data analytics across our entire fleet and looking for similar conditions in different localities to try to figure out, issues relating to corrosion and the life of the equipment and how its health, deteriorates over time, and all around optimizing. And we want to look at that broadly across the world, essentially. So we need to be able to do that make an apples to apples to apples comparison to be able to do those kind of analytics. To do that, you need uniform identifiers. So if we do happen to pick a new system to load this data in, going forward, that we will pull it all together and load that system with a unique identifier that's consistent across the enterprise. So that's an opportunity for us. And then with our digital platforms, be able to have uniform data services and uniform formats that come out of this thing. The REST services, the ODBC assets that we're going to lay out there for consumers in the environment. If we can do this, and this is, we've spent the last year building sort of this base product, going through the optimization, going through some of the performance tuning, and we're now at the cusp of where we're going to start ingesting in mass multiple data sources and bringing additional data sources in. And if we can do this, and we've done it right, we're hoping that within 2 to 4 weeks, we can do the whole mapping and merging and translation rules, a combination of business analyst and developer, if necessary, in about a 2 to 4 week cycle after we extract the data. We'd like to be able to provide this to downstream consumers for data science analysis, to blend it with time series data that we are now trying to get into, put the context around our time series data so we can do additional analysis. And if we do this with equipment, and facilities, and it's related satellite data, we can switch over to other types of data within our organization because, we deal with wells, we deal with land contracts, we deal with a whole host of other information objects that we use to run our business. And so just take this framework and repeat it, in a consistent manner, in a configurable manner across other data types. So that's why we kind of built as one of the requirements of the product we put together. And at some point, lift and shift this whole environment up into the Azure cloud. Our company right now, we like things internally, so we are working with the cloud, but it's trying to do this kind of level of system, getting it into the cloud itself is a major challenge. So we'll do that as it makes sense to do so. And with that, I'm going to turn it over to Damon, and who will give you just a little bit more context about some of the things under the hood that we're doing. Thanks, Damon.
Thank you. One of my favorite projects, glad to see Robert here, and of course Lance coming to talk to us. I've been working with Chevron for a while, and I'm impressed with what Chevron's doing. So I'm happy to share it with you. But I guess my main role here, switching over now to the MarkLogic content, these slides, is to tie it back to, well, how does that work with MarkLogic Data Hub and Smart Mastering and Data Hub Service? We just got this announcement that Azure Data Hub Service is on the way. So that'll make that lift and shift a lot easier. So just to redefine mastering, potatoes and potatoes, right? So to create that single, the golden potato. I try not to say golden record too much, right? Because what we're really doing is we're combining and maintaining all the data, not deciding necessarily what's right and what's wrong, but have that one piece of equipment represented in one way so that everybody across the enterprise can get consistent results and get their data from one place. So the things that Lance was just talking about was matching and merging. I'll throw in there provenance because Chevron does do great things with provenance. That's basically how we break up mastering, right? And at least I hope that's right. We have Justin here, who's the master of mastering. That's about right, right? Mastering, merging, provenance, anything else? Those are the three. Okay, we stole it from Justin. So doing that fuzzy match, and then with Chevron's innovations about putting the confidence score on every attribute to really understand the data at an attribute level and know what to trust, that's a big deal. Having the merging come together, and they have it's built into Smart Mastering as a capability to plug in custom rules. So in one or two places, they do something very particular. They've plugged in a custom rule to do something that we didn't anticipate in engineering. We gave them that flexibility in the field to do what they needed to do. For instance, put on the confidence score based on how the merge happened. And then tracking the provenance, whether that's how things got merged, what field comes from what source record came from what raw record of those, what was it, 14 work order systems?
That's a lot, yeah.
Yeah, of 4 different varieties, to know what comes from where so you can trace it. And then a little bit of a difference in the MarkLogic approach, we're focused on how we enable a data hub. So we're not necessarily going out to be the be-all, end-all of mastering. We're trying to get the data clean and consolidated so that when Chevron runs a report and they're counting how many pumps failed of a certain vendor in a certain climate, that they don't get double the number because of data duplication. Hi.
Years ago, I invented a thing called ProAct. It was root cause failure analysis, stable defender analysis, for .NET environment. So do you read this into failure due to cyber attack, or are you doing it different?
Can you repeat the question in the thing so it gets captured?
Right, so one of the reasons why,
Oh, well, I'll just repeat the question. I think you were asking if this relates to tracking failures due to cyber attack versus some other kind of failure.
I did ProAct back in 1997. I was the global thing for Eastman Chemical, and didn't come around until about 2012 when I was working in robotics. And so I work in data pods now, not data hubs, but same things. So the question is, when we get into defense, military-based continuity of operations, microgrids, how do we evolve the dashboards? Trying to get a common knowledge reference. So now you've got all this external data that could affect your sensor drifts. And so how do you wrap in what your data hub is doing to do that real-time intelligence?
Well, but one of the things is you just defined for me what I would consider an information object, a failure, an equipment failure. Okay, so, and there's going to be many reasons why that equipment would fail. So, that's an entity. It's a relationship from my master entity of equipment to the failure itself, and conditions and attributes around that. So for me, it's a modeling exercise, plain and simple. It's a business request, a business requirement. I would model it. I would find the source of the data, and I would hook it up.
And then you would just adapt your dashboard to...
Yeah. I mean, IT hasn't changed. I mean, you don't. There's no magic fairy dust here that says all of a sudden things are easier. You just have to do what you have to do.
Thank you. And then, I mean, maybe this is tied into that, valid reporting and analytics. So by getting the data in one place, Chevron's been able to see things properly, count things properly, understand duplication. And really the numbers don't come out right if you've got duplicate and disparate data, because pump 123 over here and P123 over there are really the same pump and you don't know it. So getting that together is really important. And so that's the value of mastering, it's right here. The different business units are basically using the same pieces of data to get the same numbers. Otherwise, somebody's got to have a roll-up report and they send it up to their executives. Somebody else, another division, does a different kind of roll-up on the same data and the numbers aren't the same. And then nobody's happy, right? Not only is nobody happy, you can't trace it back, because there's no data lineage a lot of the time, to why those numbers are different. So this gives everybody common data that they can rely on, and that makes the data into clean data. Things that aren't mastered, in a sense, are not as high quality, right? Until you can say this is really the single item and everything I know about it, you don't have accurate information. And that takes us to provenance. And so I say this a lot. If you haven't traced the lineage of your data, you don't really have trust. I was talking, I think it was somebody in medical, and they were saying, sometimes I might get a record from from an HL7 record in medical, and it says, this person is not allergic to penicillin. Well, that's great. Am I going to pump this guy full of penicillin and assume he's not going to die? Not necessarily. I need to know who said that. Was this his primary care physician who asked him? Is this, an allergist who tested him? How long ago did that data come in? So unless you know where the data come from, is this a record that it was repaired from the repair system, or is this an inspector who says it was repaired, or is this some other kind of data source? So to trace that back is important. So what Lance was primarily talking about here was this harmonization and smart mastering capability. I would say also some policy application. One of the things I think Chevron's done the best is to break up the team so you have one group of people who are really focused on business analysis, a much smaller team who's writing these 2 or 3 custom functions that are needed to do something special, like put the confidence on every attribute, and to allow those teams to work together effectively. So to implement policy as policy, and then do a little bit of engineering and real coding when necessary, but have a factory and a machine to crank that out with this target time frame of a new data source in 2 to 4 weeks. That's, I think, where Chevron's really standing out and doing great work. And then, of course, using the smart mastering, which is also policy driven. You make, and I think you saw it in some of the keynotes, you make a list of fields and what you're going to do a fuzzy match on, what you're going to do a hard match on. They also put in some data quality rules. Higher quality data is going to match better. They broke that up into different functions that function together really well. So that was really great. And I'll just sum it up. So obviously mastering is bringing a lot of sources together. When you bring data from many sources together, you're going to have the same entity pop up. Obviously the inspection system and the maintenance system are going to have the same items, right? The same heat exchanger. If you have medical systems, right? The same person is going to pop up in multiple systems. You have to figure out that Bob Jones and Robert Jones are the same. You have to figure out that P123 and Pump 123 are the same. So that's just the nature of integrating data from a bunch of different silos. We as a company, MarkLogic, almost had to go into mastering because as we bring in more and more data, we're getting more and more duplicates, and we have to help you deal with that. So that's where mastering kind of came from in our world. I also want to, I think this is important to remember. We talk about silos. It's almost, is silo a 4-letter? Silo is a 4-letter word, isn't it?
It is a 4-letter word.
So I have a couple minutes. I just want to remind everybody the silo is a perfectly good functioning, sometimes new or well-maintained, well-engineered system that works fantastically well for the division that built it. Whoever's doing inspections on the Chevron equipment, I'm sure is doing a fantastic job with their inspections. They're tracking it the way they need to track it with their hierarchy. Maybe they're putting a couple extra little syllables into some of the fields to make the data make sense to them so they can keep the well or the platform safe. Now, somebody else does it a different way and puts a little different information in. It's when you try to bring that together into the overall universe of company-wide data that you have a little bit of a conflict. So this is to allow people to remain agile and flexible out in their individual units, and then also do the global thing in a literally harmonious way. So dealing with variation and differences, so different entities and different sources. Obviously data hub, classic data hub and harmonization. Same data, different formats, different systems, different these hierarchical keys. And then another Chevron high point, how they clean their data. They take our mapping rules. They don't only map data to the same field value, they map it from a funny value that might have some missing hyphens in the social or whatever. They use our mapping technology to actually map it into cleaner values, which was very innovative. And at the end of the day, expose that consolidated data to the entire enterprise so everybody can be reading off the same sheet of music. Okay, so I just wanted to tie that back to some of the MarkLogic stuff. But with that, I'll hand it back over to Lance, or I'll answer some of the technical things.
Yeah, we're available for any questions. I think one other thing I might talk about, the fact that the data being XML and whatnot, is I can structure it in a way that helps me. I can have the enterprise view, the envelope that's the enterprise view. I can have a section within there that is extended attributes that are unique to a particular class of equipment. And then I can have a set of attributes there. If I can't get a business unit to completely align with my view of the world and they swear they need to have their own attributes for a piece of equipment, I can compartmentalize those in a nice little section inside the data format as well too. So the data types help me, and the structured, semi-structured format helps me organize and manage and enforce standardization and some diversity in a managed way with this type of approach to the technology, which is really, it's a kick up from relational. And I was a relational guy. It took me a while to get onto this and really, understand what I could do with it.
And I think we'll take questions. Does everybody I'm curious, I'm genuinely curious about this. Who really has a gut feeling of what mastering is? Is that a common thing? Who's a little bit I kind of get it. What the heck is mastering really all about? Nobody wants to admit it? A couple people? All right. About 2 to 1 maybe. I'm right there with you. It's been a long journey.
Is this considered like a history of record too? Oh, I'm sorry. Is this considered like a history of record where you can go back? So I heard earlier in another presentation that as records or things might change, there's a history of that change, a lineage. So.
So the idea is that this is an integration database, right? So we have systems of record, which is where the data is officially recorded, which we even have more than that. We have systems of origin, which hopefully will eventually roll up to a system of record. Then when we bring this stuff together, it's really for integration purposes and we use the term trusted source at times. And then that trusted source can be kind of turned over and dumped into the data lake in a published area for a bunch of facts. It could feed dimensions in a data warehouse structure. It could be delivered over into, it could be served up directly through web services for a consumer that's just interested in the dimension data itself. So, there's a lot of things that you can do with this. For example, if we're not tracking how data has changed over time, okay, there's nothing stopping me from creating an entity that is an equipment history record. And basically, do what you would do where you would take the current record, move it over, and timestamp it and say, this is now no longer active, and this is the new current record. And I might orchestrate that through a process API, change out equipment, and then go through that whole process. These are the types of things that we're looking at in the digital platform ecosystem that we're starting to put in place, is how do we define from these initial requirements, when we start delivering them into systems and this bigger ecosystem, what do we need to do to facilitate things like that? Because the equipment history isn't necessarily tracked in these systems, these historical systems and legacy systems that we have today. Mm-hmm. We would like to have it, but it's just not there.
Gotcha. Thank you.
Sure.
So what kind of model would you use for this? What kind of model would you use for this environment?
Well, I'm trying to understand, so like a data model, or?
Would you use like bubbles of thought for this, or would you use a dimensional model? What kind of model would you
okay.
use?
So the way I've thought through it is, I was kind of a data warehouse guy in the relational sense, and so I said, this XML structure is just a flattened dimension in a data warehouse concept. And at times I'd put it all on the table. Maybe I might want an outrigger table if there's something that I didn't want to put in there. The thing like the history, if I don't want to, stuff all my history data in with my current data, I might split it out. And I've lost track of the different forms of data warehouse structured models, type 1 through type 6. I think we're 4, but I don't remember exactly. But it's for me, it's just a data warehouse structure with an XML data type.
It's a canonical model.
Yeah.
Yeah, and I'll add to that because it is a document model and you have this XML in this case, sometimes JSON, everything's a document exactly. That tends to line up to the intuitive objects like a piece of equipment, a work order, a repair activity. So it tends to line up a little more to the business entities.
Other questions? So you spoke a little bit about you used to be a relational guy.
I'm still a relational guy.
Can you speak to some?
Okay, I think we're done here. It's still relational. We're cutting the.
Can you speak to some of the challenges that you had to overcome? Maybe just your mindset, maybe the skill set that you had to adapt to as you were transitioning to the use of MarkLogic.
The challenge is this is a complex technology, as is any of the technologies that we're getting into this day. The sprawl of technologies and how many things we have to consider is getting exponentially harder. So this was a step up from a guy who, we wrote apps and hit a relational database, and sometimes we did 3-tier. but there's a lot more pieces and a lot more points of failure in creating a whole chain of responsibility in building systems like this. So getting the OC to first understand the technology, be able to develop in it, and then administer it. We're all about continuous integration, continuous development, so we need to be able to do push button releases and push button builds and all that. I mean, that's a lot for a development team to kind of go up the learning curve on, and that's why it's taken us a year. So it's coming from ground zero, training people, and like I said, we're still OC challenged. We still don't have enough people that know how to develop in the technology and to surface up all the use cases that we're going to be going and moving with this and other technologies that this will feed or attach to it. So that is a challenge.
I think Len said he's a relatable guy.
Relatable.
Mastering every man.
That's right.
I think we have time for one more question.
Noticing everybody up front asks questions, in the back, not so much.
If I walk back here.
Oh, there you go. The very far back.
I'll have to represent the back of the room at this point now. For the cleaning up of the data that you're doing, are you doing all of that in-house? Are there third-party tools, technologies that you're using, whether it's for a static file or a live stream of information?
So there's what I'm doing, and then there's what other groups in my company are doing. So I'm just one thread of a lot of other things that are going on. I would like to say they're all interconnected in an exceptional way, but sometimes it's a big organization. A lot of things are done in different ways. So we are doing our best to correct the data for the silo that we've carved out for our initial requirements. And we're trying to deliver that standard of data to as many people as we can talk into using us as a source for doing that. And that's a political, challenge to walk through all the groups to be able to convince them for us to do that for them, because everybody kind of wants to do it themselves. So that's a challenge that we go through. We have lots of other data quality initiatives with other flavors of technology going on at any given time. We've tried several times to kind of wrestle all those together, and then they kind of go back out to the edges again. So it's just the nature of doing business at our company.
Would you describe the data mapping you're doing as data quality work, or do you think of that as something separate?
There's an aspect of data quality to it, but it's really standardization and consistency, which is an aspect of data quality. But we want to do the most good that we can as quickly as we can in time to make a difference. And we have lots of projects that go on that are zombie projects that go on and on and on and on and on. And my goal is to not be one of those. Is I want to deliver stuff to my customers in time to make a difference and get ahead of the next bright shiny light that comes along that somebody's going to sell a manager on and go off and do. So go ahead.
Have you come up with any guiding principles that tell you what to use MarkLogic for and what not to use it for, based on your experience?
We are developing those as we go. Like I said, we spent a lot of time base product development, building the user interfaces, performance tuning, and we're in the process of wanting to kick off and start loading a lot of data. So we have some things that we think are going to be happening there. Again, I'm kind of drawing a boundaries. I'm going to go after dimensional data, things. Okay, there's technologies that deal with facts and cubes and BI. That there are other technologies out there, whether it's relational or cubes or whatever, that have been doing this for 30 years or 20 years or whatever, that are probably better optimized. So the trick is to find out where you don't try to be all things to all people, and that's a challenge in our organization, because as soon as we find something as an IT organization, we got to make it be, there's a desire to try to make it work for everything, right? And that's never quite worked out well in any of the situations that I've ever seen within our company. So, a data warehouse is a data warehouse, and it does great things. A master data system serves its purpose. A data lake and a self-service architecture for, being able to have data scientists go off and use as a playground, perfectly good. Data catalog. A time series database, for doing high frequency time series data at infinite scale. Okay, that's a unique technology. The ability to bridge between time series and master data and establish that context, that's a requirement that needs to be filled by something. And so those are the ways that I think through how you look at the whole enterprise.
Well, Lance, thank you. Give a shout out Robert Kimson, who's part of the Chevron extended team, part of this. Damon, thank you. And thanks everybody for coming.